Hello, it's Keith here, and this is lesson 18 of the Sam Coupe series of Z80 programming tutorials, and we're looking at the Sam Coupe again. We're going to be looking at the final part of the code on this system, and that is the title screen and the main loop. So we're going to be having a look at that today. Now the title screen you can see above me here, and I think it looks fantastic, but I'm probably rather biased on these things. The important to notice about it is we can change the colours if we press C between the three different kinds of 3D glasses the game supports, and if we press the 3 key, we can toggle into boring old 2D mode if we're a little bit boring. We can also press the K key to toggle between joystick and mouse support, which is all that this version supports. So we're going to go over the source code today and look at how that functions in the code. So over we go, let's check it out. So here is the title routine. We've got this loop here, and we're using BC as a counter, which will be a delay until the next showing of the introduction. The introduction will show again if we wait long enough. We're then reading in the mouse here. We're processing the mouse mainly just to get the fire button. We don't process any directions, but we need the fire button. We are reading in a row of the keyboard to get the K key here, and we are toggling between the key modes here, and we are showing the key mode to the screen as well. We're just doing that just here. So that's how we change between the keyboard and the mouse function. The mouse routine here actually will read in from the joystick as well if we're using the fire button of the joystick to control the game. What we're then doing here is we're checking the C key, and we are changing the palette if we're changing the colours. Now that's of course for the 3D glasses. And we're also checking for the 3 key to see if we're going to toggle 3D mode on and off. Now the 3D mode is actually a trick on this system. On the Amstrad CPC there's two versions of the title screen. A 3D version which is just one colour, black and white for each eye, making the 3D effect because that system can only do 4 colours. But the Sam Coupe can do 16, so it's 4 colours per eye. And so rather than having two versions of the graphic, the 2D version is actually disabling the colours to make one of the eyes have no effect, setting it to the matching colours of the other eye. And that's why you can see Sam Coupe 3D even in 2D mode on this system, whereas on the Amstrad CPC it would actually just say Sam Coupe there. There's a bit of a tweak on that system. So that's what we're doing there. Now the final key press we're checking is the H key. If we press H, we will jump into hard mode, and this simply starts as level 128. So we can try those really hard levels if we think we deserve a challenge. So that's what that does. The way that works is simply we skip down to start game hard here. And that at the start of the code here, we set the level number to 0 if we're starting normally. We set it to whatever's in the accumulator otherwise, and the accumulator's been set to 128, so we will start at level 128. What we do then is we set the song. Now, as I said before, the Arcus Tracker version I'm using is a modified version, and it always plays from the same memory address. So we copy the song game, which is the main game music, to that address when the game starts. We're then resetting all the default values for our game here. That will just initialize all of the game data, the variables the game uses, back to a default setting to make the game work consistently and start the new level. We then initialize the level. This sets up the enemies and things like that. We repaint the screen, which draws the initial status of the screen, and then we fade the screen in, and now we're ready for the main game loop. Here is the main game loop. So this is the main loop that runs during the gameplay. When the game ends or the game player dies or gets to the next level, it will branch out of this. But basically what we're doing is we're reading in from the mouse, getting the current position of the mouse. We're then running this update sound sequence. The game only uses simple sound effects, so Arcus Tracker does the music, but the sound effects are still done by Chibi Sound just for compatibility. I was originally planning to port this to a lot more systems, but it took too long to port, so it wasn't realistic, unfortunately. So anyway, Chibi Sound is using a simple sequencing routine where it can play a sequence of pitches, and this will update for the next one. We're then going to check for some keys. First, we're checking the pause key, the P key. If this is pressed, then we stop the music. So if maybe the player's got a telephone call or something, we wait a while before we do any more processing, and then we start reading the P key again to see if the player has unpaused. And if the player has unpaused, we wait again, and then we continue. That's just a very crude debouncing routine there, so that if the player presses P, it waits a while before checking the P key again to release it. We're checking the space key here for reloading. You can reload by shooting off screen or with a right mouse, but you can also use space if your joystick only has one fire and things like that. So that's what we're doing there. We're then checking here for the S key. Now this will toggle the speed. If you're using a mouse, you might want a very fast mouse, or you might want a very slow one. Now the mouse speed uses a combination of 2 bytes per speed, and what's being done here basically is we've got 4 possible combinations. So we're selecting the current combination, we're then doubling that up, and we're reading in the new speed in from the bank of possible speeds, and we're writing it to the cursor move speed parameter, which is the current one, and that's used during the mouse reading. So that's what we're doing there. We're saving that into that variable so that we don't have to calculate it from the offset there. We don't want to do all of that every single time we process the mouse. We've got another check for the C key to change the palette here. They're just changing the colors. We've got a check for the 3 key here, and we're changing the 3D settings here, but this time it's different. In the gameplay, if we start the game, when we use the 3 key, we can toggle between 3 stereoscopic depths. You can see here we're able to toggle between 3 possible depths there. So that is that's quite different from the title screen, which was only on or off, and that was because the 3D was pre-calculated into the bitmap data, so we couldn't change the depth very easily. What we're doing here is we're updating the game tick. The game uses a 16-bit tick, and that tick is used to decide when the bats should move and things like that, when the player should lose life. As the game gets faster, we can change those parameters to work on more ticks. So the tick is the controlling factor for the speed of the game. Now what we're going to do is we're going to update all of the sprites. We're going to update B sprites and IY points to each sprite. We use the animate routine to update each sprite. That will calculate any changes to the position. If the sprite has changed position, we're going to redraw it in its new position. It also does collision detection, things like that. We're moving sprite data size, which is actually 16 bytes because there's 16 bytes between each sprite. Every 7 in this case, depends on the system, but every 7 sprites we're going to update the mouse. The reason for this is maybe every single sprite has coincidentally changed at the exact same time. Well, that's going to take a lot of calculation time, and that could cause our mouse to jerk as we're moving it around. It could be very jerky in its movement. So to get around that, we're basically making sure that every time we've done as many as 7 sprites, we're updating that mouse. If none of the sprites moved, we've probably got plenty of processing power, so it won't matter. And if they have all moved and it's taken a lot of time, that'll keep the mouse nice and smooth. What we're doing next is we're checking the tick, and we're checking the bottom 4 bits, and if they are 0, we're going to a routine which is incorrectly called mo fire held. It should be no fire held. Typo there that got into the original code and got transferred across all the different systems, and I keep forgetting to remove it. Anyway, that is for the minigun. The minigun, or the chibi gun as I call it rather, is an automatic weapon, so you hold down fire and it will fire. If you wanted to make it faster, you could change this and you could make it a smaller value and it will fire faster, but you will run out of ammunition fairly quickly, so you probably don't want to do that. Anyway, we're using the fire button routine here. If the minigun is selected and the fire button is held and the tick is one that we want to actually fire the minigun, so that's what we're doing there. Then what we're doing here is we're checking the regular fire button. This is just the normal fire. And if it is pressed, we're releasing it. That's not automatic, so you have to press and release and press and release. And then we're firing the bullet. Finally, we're updating the cursor position again. We've actually done this many times during this sequence here, but we just need to make sure it's up to date again. And then we are showing again, jumping back to the top here of the main loop. So that's the main loop, and all of that happens again, and it will continue to happen until the level ends, either because the player has won the level or because the player has died. But that's all in the multi-platform code. Anyway, that's all we are covering today. Now you can go to the website, you can download the pre-compiled version of this game, and you can download the source code. And as I always say, you're welcome to take the source code apart and take bits out of it and make your own far better games out of them, and you can do that for commercial purposes if you so wish. I welcome you to do that. If you've liked what you've seen, please like and subscribe. If you like the videos, it encourages me to make more silly little games and put them out on the internet. And if you subscribe, well, that will help you see the new stuff that comes in the future. If you want to support my content in other ways, you can back me on Patreon. You can also buy my book, Learn Multi-Platform Assembly with Chibi Akamas, covers Z80, 6502, 68886, and ARM. It's available from Amazon now, so that is something that's out there. And I'm also giving it away free to my $5 and more patrons now, as a digital copy, that is. So if that's what you want to do, please do that. Anyway, I hope you have a lot of fun with your programming adventures and you have a lot of success. Thanks for watching today, and goodbye.